All right, well, it's going to be a tough act to follow, but we can certainly try. I have here with me, it's my great distinction and pleasure to introduce Uri Kolodny, Alex, and Jack from StarkWare, Matter Labs, who famously developed ZK-Sync, and StarkWare. So today we'll be talking about blockchains and how they scale. And I think an easy way to do it would be to start from first principles and ask ourselves, what is a blockchain and how does it scale? And specifically, what different features of the blockchain need to change for the networks that we have today to be able to scale? Uri, I'll hand it off to you.
Can you hear me? Yep. So blockchains, I suspect I don't need to tell the audience at Token2049 what that is. We're trying to build a permissionless decentralized ledger which can scale. The problem with blockchains, of course, is that they do not scale. Firstly, because in terms of an open permissionless network, layer 1 blockchains as they stand today, there is really no notion of division of computational labor. And so all nodes in the network essentially perform the same work over and over again. And because of that, they cannot scale. The easy cop-out is to go for faster, stronger machines. Of course, faster, stronger machines exist. But by doing so, and this is not a technological limitation, this is sort of an ethical principle, by doing so, by going for faster, stronger hardware, more expensive hardware, we hurt the decentralization of the network. Because all sorts of players who would otherwise participate are priced out of the market. And so that's sort of the basic challenge that layer 1 blockchains face. And that's why a whole slew of approaches and technologies to create layer 2s has been going on for several years now. We're a member, StarkWare is a member of this set of participants, set of players, with an approach often referred to as ZK rollups or zero-knowledge proofs. We prefer to call them validity rollups because in their current incarnation, these things actually do not involve ZK zero knowledge. That's the short answer.
Alex, thoughts?
Yeah, I'd like to add that blockchains, for me, if you look higher level, they are coordination mechanisms, economic coordination mechanisms between different people where you have the ability to interact trustlessly. And this trustless component is the most important thing we have. We could have economic coordination using authorities, as we've done in the past with banks and with institutions and with different other means to coordinate and agree on what's the economic reality is today. But the innovation of blockchains is going beyond trusting individual people or certain trusted actors. And technologically, we achieve that by building peer-to-peer systems that do not have any central authority, do not have a single point of failure. And the way it was originally constructed by Satoshi with Bitcoin, and which wasn't the idea that was inherited by all the existing blockchains, is what's known in the Bitcoin community as the don't trust, verify principle. That you essentially verify all of the work that happens on the chain, you don't have to trust. Problem is, with a naive approach, it leads to, technologically, to quadratic work. Like if you have n participants, then each of these n participants have to do n pieces of work to verify the state of the chain and all the activity that happens on the chain. And that is not scalable beyond, that goes very quickly to the degree where it's not sustainable. And the idea of layer 2s is to use some more sophisticated methods to either shard the execution, shard this verification of work, split it in multiple parts, and make different groups of people that check work in each of the group, or to use something way more advanced as zero-knowledge proofs, for example, that can succinctly verify, succinctly attest the integrity of the computations on very large array of data, so that every participant can check the integrity of the entire state fully trustlessly.
So, Alex, why is it that you can't do that on the layer 1 network? Can you generate these succinct proofs on the layer 1?
You can do it on layer 1. In fact, there are layer 1s that try to be succinct. Mina is one example of that. I'm not sure. I actually cannot call any other one out of the top of my head.
Zcash, in a way, yeah. I mean,
Zcash are on the path to accomplish that, right? But I think the more important aspect of layer 2 is that you can experiment with something. Like Ethereum is already the king of layer 1 smart contract blockchains. It has a very broad audience. The token distribution is really well done. It's really decentralized. It has a culture and community that is very principled, that is based on ethos and values more than on some like ephemeral incentives. So it's great that we can bring these new technologies to the world of Ethereum without disrupting, without reaching consensus with everyone that this is the right way to do it or this is the right way to do it. We can experiment and then let the best approach win.
Okay. Well, Ethereum, like you said, is sort of the king, the smart contract platform that we the first instance of these platforms started with Ethereum. So, Jack, what do you think is missing today in Ethereum that we need to start thinking about these layer 2 solutions, these off-chain methods that will enable Ethereum to scale?
Yeah, I think, hello, testing. All right, is that okay? I think so by the way, the three of us have been working in this space for a really long time, seen each other at conferences for, since 2017, right? So anyways, we've seen the history of this problem. And one of the interesting things, I think that there's a greater appreciation now around segmentation of users and use cases. I think before it was, what's the best way to scale Ethereum? And there's just one answer. And there's a lot of people fighting, a lot of smart people arguing about what that best one answer is. And I think the question has changed a little bit too to like, what's the best way to to scale Ethereum for these types of use cases? Maybe a gaming application has a different set of trade-offs they care about than a DEX that has huge financial volume. So I think there's also more specificity as these different smart people and businesses and approaches come together to solve the problem. I think it adds a new wrinkle and a new twist to the equation. But in general, I mean, from the inside looking out, Ethereum is clearly the place where developers are building, and it's the place where people are looking to scale. You're looking at Ethereum plus, as opposed to, let me start from scratch and take the most powerful machines and brute force this thing. I think that's, from our world, not the answer.
There are a couple of different approaches today. One which pays respect to sort of the hegemony of the Ethereum virtual machine, which is at the core of the Ethereum network. And there's another approach that says Ethereum was not designed to natively host a lot of these cryptographic primitives like snarks or starks. You'll hear people talk about the way you generate these proofs. StarkWare decided to build a new virtual machine, one from the ground up, that's compatible in some ways with the Ethereum virtual machine, but fundamentally sort of introduces new primitives. Mata Labs has a slightly different opinion. It says, or they think, that not only is it interesting to try and develop a one-to-one compatibility with Ethereum, but the bet is that people will continue to build on Ethereum. Uri, what do you think?
The way we see this, we were basically forced to develop Cairo, which is the programming language at the heart of StarkNet, the decentralized permissionless network that we're building out. And we were forced to do this because the alternative was to deal with raw math, if you will, and that's too complex and too dangerous in terms of the security of the code that's created. And the Ethereum virtual machine couldn't provide us with what we needed there. And so we concluded that what we need is a new stack. And if you actually start looking at the layers that are forming and what's done in each layer, you come to the conclusion that Ethereum, for the most part, is going to be the security layer for the in the coming years. And so then the question is, what happens on layer 2 or what happens on layer 3, which is a concept that we introduced about a year ago. We published about this vision, which we think is very exciting. And now the question is, what are the needs of those additional layers? And they're fundamentally different from the needs of Ethereum. Specifically, these are layers where a lot of computation is going to take place. And Ethereum hasn't been able to support a lot of computation. And so if you look, say, 5 years out, the question is, applications that are then dominant in the future, what language will they be written in? Is it Solidity or is it something else? And we think they will be written in whatever is the best tool for those environments. I should mention in this context, 4 weeks ago, 20 community members in the StarkNet ecosystem started working to build out a ZK-VM, which is the term in our neck of the woods used to describe something that runs in layer 2 over a zero-knowledge system that is still EVM compatible. And 4 weeks later, we have 85% coverage of Ethereum opcodes and ERC20 support and all sorts of exciting stuff. So for me, more than anything, it demonstrates the expressivity of Cairo as a programming language. But I think that at the end of the day, people will want to do the most efficient thing. And the legacy of the EVM, which is a few years old, looking sufficiently far out, I think is going to be a minor consideration. That's our bet.
Alex?
I agree with Uri that eventually people will want the maximum efficiency, and we will be having applications that are unimaginable on blockchains like Ethereum today. Our take is, and by the way, we were not implementing bytecode compatibility of EVM. We actually took a very similar approach. We've built a new virtual machine from scratch, similar to Cairo, that is designed to be most efficient in the ZK execution environment. What we did there was, why we called it ZK-VM is, for us, EVM is about the set of standards that standards about the interfaces that developers expect. So we are a team of developers, and we see developers as our primary audience of users, and we want to make the developer life as easy as possible for the maximum adoption of the platform. So what you can do with ZK Sync is you take code written in Solidity and you compile it into this efficient virtual machine. We just made sure that all the patterns of interfaces, of the standards, of the conventions that are present in Ethereum can be transferred one-to-one, specifically with regard to security and censorship resistance. So for example, that you can take any transaction and enforce it from layer 1, so it cannot be censored at layer 2, etc. Things like this. So we just made sure on the virtual machine level that that's the case, and we believe that for the near future, Solidity is going to dominate the space just because standards are sticky. If you look at like modern macOS, you still have the terminal with POSIX compatible commands from like Linux from 1970s. If you look at modern web browsers, JavaScript is still the dominant language. You have different flavors. You have TypeScript, you can compile, you can WebAssembly, etc. But like JavaScript was what was the lingua franca of the web for the last 20 years or more. So we believe the same thing is going to happen with Solidity and EVM. It's just going to be the standard for a while because there are so many tools and product and libraries and services written for the EVM environment that it's just going to be there for a while. Eventually, then, people will be using more efficient tools, and we'll see what market will crystallize at the end.
Speaking of tools, I know SKALE has been working on a lot of tools under the hood. Jack, maybe you tell us a bit more about that.
Yeah, and well, first I want to just roll on this because there's a theme here. So I think this is a theme that you find within the Ethereum ecosystem of people who really understand EVM, which is different than other chains that just fork Geth and go, we're EVM compatible. But we also spend a tremendous amount of time optimizing EVM, and we have a C++ Ethereum instance and a lot of low-level networking optimization, and it's just because EVM off the shelf is this massive bottleneck. It's obviously powerful, proven language, and proven virtual machine, but I think people that understand it well are doing other things with it, and there's a common theme here.
I want to add there that there are many, many benefits, to the EVM compatibility as sort of a general approach. But if Ethereum could have handled, not 15 transactions a second, but 15 million transactions a second, I would have said, fine, let's all bow down and accept this as is. But I think that it's very important, that stuff like Solana and Cosmos and Aptos, and all these different approaches and different attempts and different experiments, I think are exceedingly important. And when people start talking about Ethereum in this context in sort of quasi-religious terms, in terms of, this is the thing and nothing else should exist, it concerns me. I think experimentation is actually crucial to success of the whole ecosystem. And I think that we should support that as a community. We should and we should adopt ideas that we see elsewhere and exchange ideas. I think that's very healthy.
Yeah, and so I totally agree. And to continue to that point, so if you look at SKALE, we took a different approach, but we also believe in modularity, right? If you have a single machine doing a single thing, you're not going to get much out of that, and you will hit your limits very quickly. Or you just have to make the machine bigger. We've used modularity to scale horizontally, so there's already 18 chains across the SKALE ecosystem, but we also recognize that someday, when we have billions of users, we need to go further. And so within these 18 chains, and hopefully it will be 180 chains or 1,800 chains, they're all working together and they're operating together, but we want to have a pluggable environment and a configurable environment, so somebody could say, hey, we have a ZK solution we like, and at the end of the day, we could partner and collaborate with the experts in zero-knowledge proofs and other techniques to get an even added layer on top of scaling. But right now, people can show up, and we have people talk to us, and 2 days later, they've deployed to SKALE, and they have 50,000 users using an application. That's happened because of the interoperability within Ethereum.
Speaking of these sort of different chains, there's this fascinating idea of app-specific chains or developing chains, so networks on top of networks that are able to do very specific functions. Specifically, I was very fascinated when I read the work on layer 3s and beyond. In fact, the idea of just adding networks on top of networks. Both, I know Mata Labs and StarkWare have been working on this for a while, and SKALE is planning to implement something very similar. So maybe we talk about that a little bit. Specifically, why it's a good idea and what's the limit to that reasoning?
So I'll start with, from the end. The limit, conceptually, we don't know of a limit. In any engineering system, there's always a bottleneck. So the honest answer is, at any given point in time, there will be limits. The idea came about layer 3. We conceived this whole concept of fractal scaling because of a need, because we had teams coming to us wanting to build out on StarkNet, and one particular team said, "Well, our revenue is denominated in dollars, and this is a public chain that you're building, and you haven't invented new physics just yet. So just like Ethereum has gas fluctuating, your network will have the same thing. And what do? How do we have revenue denominated in dollars and our cost structure just fluctuating all over the place?" And what they said, and of course, you can try and mitigate that, okay? You can't solve it categorically, but you can try and mitigate that by giving them more control. So specifically, the metaphor they used, which I love, is noisy neighbors, right? So if you exist on Ethereum and you're Uniswap, the minting of apes, it's amazing how the metaphors turn quaint in this ecosystem now. Apes is now like, I sound like a dad. But anyway, so the minting of apes is your noisy neighbors, and if you're minting apes and there's a rush to the exits because SBF or something, then those are your noisy neighbors, okay? So people want applications in certain contexts, say, I will forego perfect composability, I'll settle for interoperability. In fact, I'll forego all sorts of benefits of the public chain in exchange for more control. I need more control. In fact, it's not only that I need more control over who will deploy on my app-specific chain, or my ability to conduct operations there with my own token. I want control over the software stack. Meaning, for example, I've witnessed the resolution of EIP 1559 on Ethereum. This is an improvement protocol for Ethereum, proposal for Ethereum, that took 2 years. And Web2 companies come in and say, I don't have 2 years to spend. I want to introduce a change. I want to do this on my layer 3 in a matter of weeks, not a matter of years. And the public chain, I understand that's a far more conservative and slow-moving beast. That's fine. But I need to be able to run my own show and to do that as a layer 3. So that was sort of, it came about because of a need, and that's the approach we're taking.
Alex, I know that you're also working on layer 3s.
Yes, this is true, and we see layer 3s and fractal scaling more generically as essentially the end game for blockchain scaling. This is the way we're going to be building the Internet of Value. The problem without layer 3s, why we can't really build it with independent blockchains, is that you cannot scale trust. With independent blockchains, trying to bridge them always requires some degree of trust that is subjective. You see the validators of that chain, and then there is some degree of, like the way you believe the messages they are passing are correct, but you cannot transfer that to different network, and then from there to another network, etc. And you cannot really also build a single monolithic blockchain system that will incorporate all of the world's value transactions. That is just physically impossible. Like, you cannot imagine internet running on a single computer or a single data center even, right? You need a network of parallel running systems, and that is achievable with layer 3s. The great thing about layer 3s is that, like, specifically if you build them on the basis of zero-knowledge proofs, recursive zero-knowledge proofs, is that you can completely scale that trust. You can be mathematically sure that the transactions that happened on some remote part of the network are valid, and you can blindly trust that network without knowing who is running it. And so you can build these completely trustless bridges that are fully seamless, that require no collateral. They are like perfect capital efficient and completely transparent. And the costs of sending funds asynchronously from any point of, like, any address on the entire network to any other address is going to be just a simple cost of a simple transfer within this network. So, and on the question of limits, essentially you're bound to, like, how limited is internet? You can add more servers as long as you have physical hardware that you can add to this network. But it can grow, like, completely uncapped. The same thing is happening here. Because all of these chains can run in parallel, you have infinite capability of parallelization and of bridging between them. The only thing that limits you is the computational capacity to produce the zero-knowledge proofs. And we're going to be pushing the limits of efficiency further and further down until we get to, like, fraction of a cent per transaction, like fraction of a fraction of a fraction of a cent, and then you will essentially go.
Depending on the sort of consensus and the type of communication that agents have in some of these networks, some of them tend to scale better than others. Some of them, if you double the number of nodes or the number of agents in the system, maybe you get close to quadrupling the sort of cost or the overhead. Some do much worse. So in terms of simply scaling the number of nodes in the network, what do you think the practical limits end up being, knowing the dominant type of consensus mechanisms that we have today? For Ethereum, for example.
So this would apply to layer 1 systems or to systems within a single monolithic consensus, because they all must be running in what I originally described as don't trust, verify environment, or they cannot trust each other. They have to verify all the transactions, so you can be more or less efficient. With layer 3s, you break out of the blockchain trilemma entirely, because you are not adding servers in a single network. You're adding new networks that are essentially independent from each other, that have very loose connection, very loose dependency. And you can do that without any limits. I mean, you're just limited by physical and computational capacity that you can provision with all the servers in the world that will be generating zero-knowledge proofs. And that to the best of my knowledge, you can only do it with zero knowledge proofs. No other method is known to me that can accomplish this completely uncapped, trustless network building.
Yeah, I want to try to just sum that up because I think that was very well said. And if you look at all three of us, I think are taking different approaches at solving this problem, but there's something similar in the sense that we've all recognized that traditional methods, if you're looking at a monolithic database, especially a blockchain, you add more servers, you add more resources, it doesn't actually add any more capacity. Okay, it doesn't add more throughput. Be like if you're writing, trying to call an Uber or Lyft, and there's a lot of drivers, but there's only a fixed amount of riders. Okay, what we're all trying to do is bring more capacity to the equation, and we do that by adding, with the layer 3 environment, more and more networks, more and more capacity. But then you have to solve for, as you add that additional capacity, what are the security mechanisms you're optimizing for, and the user experience. And I think all of that comes together, and the goal is to let as many transactions process as possible while having an understanding of physics. Okay, it's at some point a database can only do so much, and regardless of how many compute power you put behind them, that will tap out. And we're trying to solve for not just the 100,000 users today that are actively interacting with the blockchain directly, but a future where there are hundreds of millions or billions of users.
Well, I think we have a little bit of time, and then we'll open it up for a bit of Q&A if that's okay with everyone. But let me ask about one particular question that I think is interesting, and that's to do with the native token on the network. We have good mental models and mathematical models for when you have a layer 1 network and you need to secure it, and in order to do that, you introduce economic opportunity cost in the form of a token. But as Alex said, when you start moving to layer 2s and layer 3s, you start to break away from this fundamental limitation of a layer 1 network, which begs the question, do you need tokens on these layer 2 networks that are native to them? Or does the layer 1 token act as the sort of master level economic value transfer mechanism? Maybe I can ask Uri first.
Well, we've come to the conclusion that StarkNet requires its own token for multiple reasons. The most important one is that this is the most efficient mechanism that we know of to allow a decentralized public good to exist and for the general public to coordinate its evolution. Now, this ecosystem is a new one compared to Ethereum, and as such has different needs, and different participants, different requirements, and so in that regard, we concluded that a fresh start makes more sense.
I think this is a really good take. The tokens are something much more than just a technical security mechanism. It's a way to coordinate communities over shared values, over shared goals, and there might be different mechanisms how the tokens are used in different communities, and so taking this to the world of layer 3s and fractal scaling, I totally believe that we will have a lot of different dApp chains or like specific community chains or specific applications, focus chains that will have tokens that work, that function differently and serve different purposes. And that is going to be a very cool thing to watch and experiment with.
Yeah, in SKALE, the tokens utilized to add security across the entire network. So if we didn't have our own native token to the SKALE network, then as new chains are added, there's nothing that bonds those chains together and pool, that you actually create a network effect of security, okay? And so I think part of it is network effects and growth and community development. But at the end of the day, payment and security are really critical components to having a token. And I think networks and network effects are stronger when you have, when tokens add value in terms of, increasing security, increasing involvement, and, add a form of payment. And some L2s don't have that, and they're using tokens for governance only. And those, I think, are, there's just frankly less of a need in that case to have the token. But in terms of these layer 3 environments, they're really critical, and it'd be hard to establish a bond amongst that decentralized group of actors without a token.
Well, the last thing I'll ask about the tokens is, again, what Alex mentioned about bridging in particular. And bridging is a very generic term. It just refers to how different networks can communicate and transfer value to each other. But they're not all created the same. In fact, if you sort of go look today, you'll see there's an entire zoo of different architectures for bridges. Some much more secure than others. But we've seen empirically that a lot of them tend to be very insecure, and very small flaws cause a lot of loss in economic value, unlike some of the dApps, for example, where it sort of could be contained. Why do you think that is, Uri?
Why do I think that is? I think for the most part, these bridges concentrate often an astounding amount of value. And so there are a lot of eyes, some of them white hats, some of them not so white, looking at this and taking advantage of every crack that they see. So, I think it's an obvious answer. It's effectively an open bounty program, and the public responds in kind.
Well, my take is that most mechanisms that secure bridges today are inherently custodian, like to some degree, or to much higher degree than like most scaling approaches that are not even ZK based. Right, so you have to trust a lot of people. So you violate this idea of not trust, and we see it, like with today's or like this week's events with centralized exchanges. Like trust, someone can appear very trustworthy, but then black swans happen, and you cannot see behind the scenes. You do not know what's really going on there and how things are secured, how things are operated, etc. So most hacks we see with bridges are actually attacking those centralized mechanisms, not the decentralized smart contracts or like math and cryptography behind those things. Centralized systems are notoriously hard to protect against hackers. There are a lot of 0 days, there are a lot of vulnerabilities, and this is why we're doing crypto. Crypto means like cryptography, trusting math rather than people, rather than the process. You trust the code, open source code, and the math behind it.
Yeah, a lot of these bridge attacks, they expose the fact that you could have the world's most elaborate consensus model. You could have this unbelievable Nakamoto coefficient, but you might have 1,000 nodes and with billions of dollars of stake, but then your weakest point of attack is the fact that there's a 3 of 5 multi-sig and a centralized server running the bridge. And if you're a government, a malicious government that says, hey, let's go put resources and attack this, this chain, are you going to go after the consensus where all the money is? No, you're going after the bridge, and that's why the bridge attacks are happening.
Yeah, you need to penetrate 3 machines and you're done.
Yeah.
That's right. If the audience has a couple of questions, we have a little bit of time, please.
So we're talking about scaling. I'm totally sold on ZK technology, but my understanding is we're still 2-3 years away from full usability. What do you think of other scaling solutions like sidechains, like Polygon, or optimistic rollups? And what's the future of them once ZK technology will be implemented?
So we met with some of we know all these teams well and respect them very much. Sidechains, I think, fall into the trap of, at the end of the day, if you click enough links, you rely on a small set of participants to secure the network. Some of the names mentioned. Optimistic rollups, we know the teams well and we respect them very much. When we started working on this stuff, beginning of 2018, they said this is all beautiful, but it's going to take way more than it will take with optimistic rollups. We have been on mainnet supporting general computation with zero-knowledge proofs, actually ahead of those players. And Vitalik, beginning of, I think, last year, said this is going to take, having a programming language for general computation, it's going to take 5 years, 10 years, all sorts. We're there. It's moving a lot faster than I think most people expected. I think it's moving a lot faster. My co-founder, Eli, has been doing research in zero-knowledge proofs for the past 25 years. And he's also one of the founding scientists of Zcash. And he keeps talking about the fact that thanks to blockchains, cryptography has seen progress over the past 5 years that it hasn't seen in decades. There's so much IQ flowing into the space. There's so many creative, engaged people working on these things. It's moving very fast. Now, I want to be very clear. There's a ton of work ahead. Right? We're far from done. We're far, far from done. But we're working on it.
Yeah, I fully agree with Uri on both points. So with proof of stake systems like side chains, they are a ticking bomb. They are, like what we've seen this week. Things are good, everyone is confident, everything is fine until it's not. And that can happen like overnight. And some of these systems experienced vulnerabilities around these game theoretical mechanisms, so like validation mechanisms that were luckily fixed in time, but they might not have been. So like for me, it's a ticking bomb. It's a huge risk for the entire ecosystem, because if they go down.
I want to add that this week it actually didn't take overnight. It was actually, there wasn't enough time for a night to, it was a few hours,
my feeling there is, one, it's a great question. I think time is also a factor. There's segmentation and who are the types of users and applications and what are their security needs, and also time to market's an important thing. And Scale has an approach that integrates side chains without the, we do a lot of things for collusion resistance, we do a lot of things for redundancy and liveliness by creating a network effect across chains. But we've had since June 17 million transactions, and we have about 1 million transactions every 3 days now. And we're really focusing on gaming and Web3 applications, that need high volume throughput. We also believe in segmentation and are excited about adopting ZK and other advanced techniques that I think are absolutely critical for other higher monetary value transactions. So, but it's all trade-offs, but one trade-off is time, and we can't just sit around and wait forever. But I think tremendous respect for all the teams you mentioned and the techniques, and I do feel like these different techniques will find the low-hanging fruit based off of their trade-offs, because it's all a game of trade-offs.
Just to add to this, regarding ZK specifically, I agree with Uri again. Like the pace of innovation is extremely fast, and we're actually surpassing optimistic rollups, because to the best of my knowledge, there are no optimistic rollup with permissionless fraud proofs, which effectively means they are trusted systems. They are not yet optimistic, but they are way more legit than sidechains, in my opinion. But on the pace of innovation, ZK Sync just launched the very first MVP of our network with ZK-VM on Ethereum mainnet, fully functional with proofs, with everything enabled, with reasonable costs for transactions. And we are going to be opening it to the developers and users gradually as our roadmap outlines in the next month. It's not going to take years. It's not 2-3 years away.
I think we're just on time. And with that, I'd like to thank my panelists. Again, this was my distinction, and I hope everyone enjoyed it. And we hope to see everyone outside. Maybe we can entertain a few more questions. And thanks for having us.
Thank you, Omar.
Thank you.